We are going to look at hydroelectric power. We need to distinguish between different hydroelectric schemes. We have to describe the main energy transformations that take place in hydroelectric schemes. We have to be able to find out the power derived from moving water masses. The most simple example of this is in a hydroelectric dam, where we have, for example, 1 kilogram of water moves down 50 meters every second. The gravitational potential energy turns into kinetic energy. So in other words, it produces 150 joules per second, because mgh is m is 1 kilogram, g is 10, h is 15, so it's going to be 150 joules. How does a hydroelectric dam work? Hydro means water, so we're going to see what happens here. Here we have gravitational potential energy. The water is stored in the dam, in the reservoir. Then we open the dam gate and water flows downhill, and the potential energy turns into kinetic energy, and then that turns the turbine, and that generates electrical energy. Sometimes we have a more sophisticated system called a pump storage system. So when electrical energy is needed, it's the same system. You start off with water which is stored in an uphill reservoir. So the water moves downhill, loses gravitational potential energy into kinetic energy. Then it goes through the turbine, and that kinetic energy is turned into electrical energy. So when you need the power, you can produce the electrical energy. However, what happens when there's a surplus of electricity in the national grid? This generator, which basically turns kinetic energy into electrical energy, can work in reverse, and then it's called a motor. So electrical energy that's in the national grid can turn into kinetic energy. So the electricity basically drives the motor, so the water that had moved down into the lower reservoir is pumped back uphill, so the electrical changes it into kinetic, and then it pushes it up the hill, and we end up with gravitational potential energy. This is called a pump storage system, and the advantage is when you need the electricity, you can turn it on, and within 20 minutes it's working at full capacity. And another advantage is that at night time, when the national demand for power is low, instead of having all this electricity in the national grid, you can use it and store some of the energy back uphill. Here we have the world net hydroelectric power generation in 2006. Notice that China is dominating here, Canada, Brazil, United States, Russia, and so on. Of course, these are dominated by countries that are very hilly and have lots of reservoirs of water at different levels. This is a famous dam, a famous hydroelectric system, which is in China. It's called the Three Gorges Dam. And in Chinese it is this. Here we have an aerial view after and before the dam was built. So in order to build this dam, which is able to produce a huge amount of power, all this area here by the river had to be flooded, which means that all the wildlife that was there had to be removed or drowned, and the people that lived there had to be forcibly removed. So the Three Gorges Dam has a total power capacity of 18,000 megawatts. It's got a head or a vertical drop of 80 meters. Now you need to find the rate of flow of water through the turbines. This could be a question you could be asked. Find the energy change when 1 kilogram drops through 80 meters. Then you find out how many kilograms per second are needed to generate 18,200 megawatts. What are the assumptions that you're making? Well, we're making the assumption that all the gravitational potential energy is turning into kinetic energy, and then that can all be turned into electrical energy. Of course, the generator is not 100% efficient, so you will have to actually have a greater flow of water to produce 18,000 megawatts. Another hydroelectric system is a tidal water storage. An advantage of this is that when it's built, the tidal power is free. It doesn't produce any greenhouse gases or any other waste. It needs no fuel. It is fairly reliable. You know when it's going to be working, when the tide is moving up or down or in and out of an estuary. It's not so expensive to maintain. The tides, even though they're not moving all the time, are very predictable. Offshore turbines, which are driven by the movement of tide, are not so don't have such a bad impact on the environment. Disadvantages: if you build a barrage across an estuary, it's very expensive to build, and it affects a wide area. It means that lots of the area needs to be flooded, and it can damage the environment for birds that need to live in this area that has been flooded. Another disadvantage is that it only provides power for around 10 hours a day when the tide is actually moving in or moving out.